Welcome you all. In this session, let us see pilot relaying schemes. So pilot relaying schemes are mainly used for the protection of transmission line sections. Okay, these fall into the category of unit protection. Unit protection means this is only the one protection zone, you don't have another zone of protection. So in this scheme, what is done is when we have a transmission line, electrical quantities at two ends of the transmission line are compared. Okay, so say transmission line sending end and receiving end you have, you compare the electrical quantities at the sending end and the receiving end. So to compare the quantities at two ends, you need some interconnection between those two, right? So for that purpose, you use a channel. That interconnecting channel or the interconnection which is present across the receiving end and the sending end, that you call it as a pilot. So there is three types of pilot relaying, or there are three types of interconnecting channels. First is a wire pilot, second one is carrier current, and third one is microwave. So this wire pilot is nothing but a buried private cable, or alternatively it is a rented post office or private telephone lines. Whereas a carrier current pilot is one in which we can transmit the low voltage high frequency signal. So that low voltage high frequency signal is in the range 50 kilohertz to 700 kilohertz. So in this scheme, the pilot signal is coupled directly to the same high voltage line which is to be protected. So this is also called as power line carrier. Whereas a microwave pilot is a radio channel of very high frequency, that is 450 to 10,000 megahertz. So among all these three, the wire pilot schemes are usually economical for distances up to 30 kilometers, whereas these carrier current schemes are economical for longer distances. When the number of services requiring this pilot channel exceeds the technical capability of the carrier current, in that case you go for this microwave pilot. Okay, so we will see wire pilot protection, we will see carrier current protection and microwave current protection in detail. So coming to this wire pilot protection, so this wire pilot relaying scheme, usually you use two wires. So you can observe there are two wires used to carry the information signals from one end of the transmission line to the other end. And this particular scheme is unit protection, as I have already told you, and it works on the principle of differential protection. So this wire pilot protection works on the principle of differential protection. So differential protection, as the name implies, difference. So it should have a difference between two quantities. So you can see that the comparison is made at the two ends by using the CT secondary currents, and you can observe the polarity as well. So since these pilot channels are very expensive, you derive a single phase current from a three phase current at each end. Due to that, we need only a pair of wires. Okay, we need only a pair of pilot wires because we derive single phase current from three phase current, so that it can carry the information from one end of the transmission line to other. Okay, so this particular wire pilot schemes are very less expensive when compared to the carrier current schemes, as well as it is simple in design and cheaper. So this particular wire pilot schemes is used up to a distance of 30 kilometer. That is what I have already told. It is used up to a distance of 30 kilometer. So this when it is a important transmission line and it is a short transmission line, we go for this pilot wire pilot relaying scheme. So there are two operating principles which I have told, that is this particular wire pilot scheme operates on the principle of differential protection. So in this there are two types. There are two operating principles, same differential protection, but it varies depending upon the connection. So one is called as circulating current principle and the other one is called as balanced voltage principle. So what you can observe here, this diagram is for circulating current principle or circulating current scheme. So if you observe here, this you have the transmission line, you have two CTs, one at one end and the other at other end. So why this is used is whatever current is flowing at this end, whether the same is being obtained at the receiving end. If not, that means there is some internal fault which has occurred. Okay, in that case the relay is going to operate, the differential relay will operate. So differential protection means it employs differential relay. So differential relay we'll see in the next video. So here you can observe that you have two coils. Okay, one is called as the restraining coil and the other one is called as the operating coil. Here the operating coil is connected across the two pilot wires, whereas the restraining coil is connected in series. And you can observe the polarity. This is the polarity when there is a normal current flowing. When there is a normal current flowing, that means when the current at the sending end and the current at the receiving end are same, you will have this polarity. There is no phase difference. In case there is a difference in the current which is from the receiving end and the sending end, then the current, the polarity of the CT will get reversed and the current will flow through this operating coil, which in turn will operate the relay. So this CT is secondary currents are being compared in this. So under normal condition and in the case of any external faults, the current will not flow through this operating coil, whereas in the case of internal faults, okay, the faults occurring in this zone, the polarity of the remote CT. So say if a fault has occurred at this point, the remote CT is which one? This. So at that end, the polarity of the CT current will reverse and that in turn will cause the current to flow through the operating coil, which in turn will operate the relay. That is how the transmission line will be protected. This is the circulating current scheme. Next, coming to the balanced voltage scheme. In this balanced voltage scheme, you can see that the pilot wires are not connected in the same way as in the circulating current. It is a cross connection, and you can observe that right now your how the operating coil is connected. The operating coil is now placed in series with the pilot wires. In circulating current scheme, it was placed parallel. So that is you can observe that is one of the main difference. And when there is when there is no internal faults, that is under normal operating condition, and in the case of external faults, external fault is fault occurring beyond this CTs. Okay, in that case the current doesn't flow through the pilot wires and the operating coil. Okay, it flows only through the restraining coil. In case there is any internal fault, then the polarity of the CT gets reversed, and in that case the current will flow through the operating coil and the pilot wires, which in turn will protect the transmission line for which it is being used. So these are the two principles in which the wire pilot protection scheme is going to operate. One is the circulating current scheme and the other one is balanced voltage. So the next scheme what we are going to see is a slight modification in the case of balanced voltage, which will have an additional feature which is direction, that is called as translate scheme. This translate scheme is again a balanced voltage scheme but with an additional feature of direction. Okay, if you observe this, you can see that there are two induction disc type relays, okay, at both ends of the transmission line. This is electromechanical type construction, and if you observe clearly, the secondary windings of the relays are interconnected. The secondary windings of this, you can observe it is interconnected in opposition as a balanced voltage system. So the upper magnet, so this is the upper magnet. So you can see that upper magnet wires is coming from the CTs. So it carries a current which is equal to the sum of all this current which is flowing through the CTs. So under normal condition and in the case of external faults, no current circulates through this pilot wires and through these lower magnets of the relay. So there is no operating torque. But whenever there is an internal fault, the current flows through this lower magnet as well as through the pilot wires, which in turn will cause the operating torque, and it will send a trip signal so that the transmission line is protected. So this the current which is flowing through the lower magnet might be small, okay, and this particular scheme is suitable for long pilots having a loop resistance up to 1000 ohms. So instead of this, there is a advanced or modified version of this which is called as translate S protection. It employs a solid state technology instead of using this electromechanical type. Other than that, the operating principle remains the same. So this is about the wire pilot protection scheme. So we have seen circulating current principle as well as balanced voltage principle. So the next video will see the carrier current protection scheme.